Welcome children for the next episode. In the last class we discussed about some of the natural phenomena that are familiar to you. In that class we discussed about how to produce a charge, how to produce charge in bodies. How can you remember it? How we can produce a charge to certain bodies? For that we rub. By rubbing we can produce a charge. Example, when a glass rod is rubbed with the silk, glass rod can attract, or a plastic scale is rubbed with a hair, that can attract small pieces of paper. That is the method of producing charge in a body. That is one of the methods to produce charges in a body. What is by rubbing a plastic scale with a hair or glass rod with a silk, then we can produce a charge. That means now the charge that given by rubbing we produce a charge, and that charge is getting to both of the bodies. For example, glass rod rubbed with silk, then the glass rod and also silk will get a charge. Then we can say as a charged bodies. Then we can say that two of them are charged bodies. And another example, we taken a plastic refill or a refill rubbed with a polythene or polyester, then also it will get a charge. How we find they got charge or not? By the attraction. That means they can attract small pieces of paper. In that way we got the idea. That means bodies got charge. Then we also produce the charge by rubbing in balloons, and also a refill. When two balloons two charged balloons when brought near, what happens? They repel. What idea we got from there? That means like charge repel. Like charge repel, that is the idea we got. Then refill charged by rubbing. Another refill also charged by rubbing. That means these two refill charged by rubbing, they are also repel. From that also we got the idea that like charge repel. But this balloon and refill, they brought near after charging, they attract a balloon and a refill. After charging, when we brought near, they attract. From that, what idea we got? Say, any one of you, what a charge, what idea we can get from the attraction of balloon and the refill? They have unlike charges. They have unlike charges. That means the charges in these two are not same. That means in the balloon and the refill, the charges are not like. From this we get two ideas. Which is this like charge? What it do? Is it attract or repel? Is it attract or repel like charge? Like charge, repel. Then what about unlike charge? Unlike charges attract. Unlike charges attract. Now There are two different types of charges on one of the charges is positive. What is the other? What is the other type of charge? Say, you know what is the other type of charges? That is a negative. That is a negative charge. Now, any one of you answer this question. A glass rod rubbed with a silk. What type of charge now the glass rod has? A glass rod rubbed with a silk. Then the glass rod and the silk will get charged. Then what type of charge this glass rod has? Conventionally, glass rod has which type of charge? That is the positive charge. Glass rod has got a positive charge. Then what about the charges in the silk? It is a negative charge. What is the charge of the silk? You can remember it. What is the charge then? It is the charge of what is a negative, silk with a negative charge. That also we discussed there. There are two types of charges. One is positive and another one is negative. Now, see, we want to know what is electroscope. What actually electroscope do? We constructed one type of electroscope in our activity with a bottle. Then what one bottle and a paper clipper and its end to what is aluminum foil. When we touch this aluminum foil with a charged straw, these leaves get separated or that are reflected apart, because when we touch with this charged glass rod or plastic straw, the charge here transferred to these leaves through this conductor. That means we can transfer charge from one body to another by using a conductor. If we brought a straw without a charge, then if we brought a scale or straw without a charge, if we touch on this, then this does not separate. That means there is no charge. That means charge can transfer from one charged body to another through a metallic conductor. This paper clip is a metallic conductor. That metallic conductor can transfer charge from one charged body to another body. And if we touch a charged glass rod here, then what happens to this aluminum foil that we hang at the end of the paper clipper? Is it a ripple or as it will remain? It will ripple. That means it gets separated or deflected or changed from its original position. This shows this body is with a charge. So electroscope is a device used to find, or electroscope is a device to detect the presence of charge. Electroscope is a device used to find charge in a body. By using electroscope, we can find is a body is charged or not. By using electroscope, we can find is a body is charged or not. So, this is the function of electroscope. What is its function? To find the presence of a charge, to find the presence of a charge in a body, to detect the presence of a charge in a body. One more thing you want to remember that we discussed in our previous class, that is what is the nature of the charge formed by rubbing. The charge produced, that charge is static. What type of charge is there? It is a static charge. That means the charge is not flowing or charge is not moving. That means so that electricity is called static electricity. The electricity there, it is called static electricity. What it is called? Static electricity. And this static electricity is producing in the glass rod when rubbed with a silk, or a plastic straw when rubbed with a polythene. What type of charge is producing there? Static charge is producing. Now, one more thing we have discussed that is about what happens to this charge. Suppose when we touch a charged body to this paper clip, this aluminum foil separated. Then if we touch with this, that means if we touch the paper clip with our finger, then these leaves come close. Then the aluminum foil leaves comes close. Again we touch this paper clip. Again we touch the paper clip with a charged glass rod. Then again it gets separated or moved apart. Now again if we touch this end with our hand, again this comes close. That means in this case what happens after charging, when we touch this end of the paper clip, its charge lost. Otherwise we say that one is discharged. What happens? The body is discharged. What is actually here done? When we charge this body by touching a charged body on this end, this foil, aluminum foil separated. After that, if we touch this end of the paper clip with our finger, then these leaves come close. There, what process happened? Discharge. That means discharge takes place. How that discharge takes place? The charge in this body moves to earth through our body. That means the charge in this foil moved to earth, and what is the way through that charge is flowed through our body. Through our body, that charge is went to the earth, and this phenomenon is called earthing. You want to remember about what is actually earthing? That also we discussed in our previous class. What is actually earthing? Earthing is the process. Earthing is actually a process that is discharging charges in a body, by connecting it to the earth. So what is actually earthing? Earthing is the process in which charges in a body we discharges to the earth. That means charge in a body is flowing to the earth through the conducting. If a charged body is connected with a metallic conductor, then the charge flows to the earth, and that process is called what is earthing. Earthing is the process. What is actually earthing? It is the process in which a charged body is discharging by connecting it to the earth with a metallic conductor. That means a charged body we connect to earth with a metallic conductor, then it's a charge we can avoid, or we can move to the earth, and that process is called what is actually earthing. Okay, actually what is actually earthing? That is the process of transferring charge to the earth. The process of transferring charge to the earth from a charged body is called what is actually earthing. Once again, the process of transferring charges to earth from a charged body is called what is earthing. Now, in our house, we do earthing. In our household wiring, we do earthing. What is the advantages, or why we do earthing in our electric connection? That means that earthing can protect our from. That means earthing can protect ours from getting electric shock due to any kind of leakage in the current. Suppose in some part of the gadgets there may be some what is electric leakage, and if there is no earthing, then if we touch we can get electric shock. But if there is earthing, then the charge coming out of the appliance that went to the earth, so earthing can avoid us getting electric shock due to the leakage of electric current. That is the advantage of using. What is earthing. Now we want to know about what is actually lightning. We want to know about what is actually lightning. See, lightning we can explain on the basis of charge produced by rubbing. Lightning we can explain with the help of charge developed by rubbing of a body. By using that lightning we can explain. That means when we rub a body with a suitable pair, there will produce a charge. That charge is a static charge, and with the help of this we can explain what is lightning. That means what is actually happening during the formation of thunderstorms. During the formation of thunderstorms. During the formation of thunderstorms, that means air molecules, air moves upward. During the formation of thunderstorms, air moves upward, and water droplets downwards. That means during the formation of thunderstorms, air moves upward and water droplets moves downwards. Once again, during the formation of thunderstorms, air moves upward and water droplets moves downward. This vigorous movement caused the formation of positive charge at the top of the clouds. That is positive charge at the top of the clouds and negative charge at the bottom. How charge gets separated? During the formation of thunderstorm, air moves upward. That means air molecules moves upward and water droplets moves downward. This vigorous, that means very speedily moving, this vigorous movement creates charge, and at the top of the cloud forms positive charge and bottom of it forms a negative charge. And near the surface, that means near the surface or near the ground also forms positive charge. That means the accumulation of these charges. That means when the accumulation of this charge becomes a large amount, when the accumulation of these charges becoming large amount, we know air is a poor conductor that does not conduct electricity, normal case, but when the accumulation of charge become in a large amount, air also becomes a conductor. To these charges. That means air cannot prevent the flow of this charge. Then air does not prevent the flow of these charges. So the positive and negative charges come close. Then it produces streak of light and sound. Then it forms a streak of what is a bright light and sound. This streak of light is actually lightning. This streak of light is actually what is a lightning, and the sound is actually what is the thunder. Once again, how the lightning and the thunder formed. See, during the formation of what is a thunderstorm, air molecules moves up and water droplets move down. This vigorous movement caused the formation of charge, which charge? Positive charge at the top of the cloud and negative charge at the bottom of the cloud. Okay, then this time what happened also near the ground there will form a positive charge. When the accumulation of this positive charge becomes enormous in a large amount, air also become a conductor, or air cannot prevent the flow of charges. So the positive and negative charge come closer and they meet, and at that time there will form a streak of bright light and sound. This streak of light is actually what? Lightning. This streak of light is the lightning. Now, actually this electric discharge can take place between the charged clouds. Electric discharge can take place between the clouds and also between cloud and earth. That means electric discharge that can take place between charged clouds and also between a charged cloud and earth. Then what are the precautions we can take to avoid getting lightning? We know what is lightning is, we can predict up to a certain extent. That means whenever there is forming thunderstorms, we can say there can occur what is some lightning. So we can take some precautions to avoid more danger. But you see, lightning happening, what are the safety methods that we can take? That means first of the safety method or safety that we want to take during lightning is that one thing we want to remember, that is no open place is safe to us. That means open place is not safe to us during lightning. That means whenever we hear, first of all we want to remember open place is not a safety place for us whenever there is lightning. Second, hearing thunder, it is an alert to us to take precautions or to search safety places. Whenever there is some lightning, it gives us what an alert. It gives an alert to take to rush safer place, to move to safer place. Then another thing we want to remember, that means suppose we are in a safer place, then if the lightning is over, just at that moment you may not come out. Take some time, that means after the last lightning, take some more time in the safer place, then only you will come out. Otherwise, there is a chance to getting what is a lightning. So, what are the precautions we want to take? First of all, no open place is a safe place for us during lightning. Then, hearing, what is hearing a thunder? Hearing a thunder, you should take or you should rush to the safer place. You also remain in the safer place after hearing last thunder. Then also there may happen what is some lightning. Then what are the methods to take to find a safer place? What are the methods to take a safer place? You can take a safer place as a house or building. Houses or buildings are safer places of what is lightning. That means if you are traveling by bus or car, you are safer if you close the windows of it. That means when you are traveling by bus or car, if there is lightning, then you close the doors and windows of it. Then it is safe for you. Then what are the things you want to remember? A house or building is a safer place for lightning. Then if you are traveling by bus or car, what do you want to do? Close the doors and windows in order to get this. And you may not travel by holding an umbrella. It is not safe for you. What are the things you can do and what are the things you may not do during lightning? On not safe by traveling upon what is a truck, car or bike, scooter, etc. That is not safe for you. And you may not stand near the field. You may not stand in the field or near the tall tree, and also open space, etc. If you are in a forest, suppose you are in a forest during thunder, then you take shelter the shortest tree. That means not the tallest tree. You should take the position of what is tallest tree. It is safe for you. Then suppose you are in a open ground or other things, then you may not stand there. That is not then if you are standing there, you are the highest object there. And also not to go to near the metallic poles or goalpost erected by using what is metal pipes, or not to go and stand near there. And also it is not safe to lay down on the ground, but it is better to squat. That means like this position, if you are sitting in the open place like this position, like this way, that means sitting in this way, that means you in this position when you sit, that is called squat. That means hold your knees, that means hands above the knees, and in between the hands your head keep your head in between the hands, then it becomes the smallest target to strike lightning. Then it becomes the smallest surface to strike. What is the smallest surface to strike the lightning? What are the things we can do and what are the things we do not do? Means that means we don't do what is while thunder or lightning, traveling by bike, open car, or by operating what is certain machines. But what you can do, if you are in a ground, not stand near, but is the poles erected by, that means post or poles erected by metallic, and not stand there and not lay down on the ground, but you want to sit in a position which I shown just before, that is squatting. Then it becomes the smallest possible chance to get electric shock due to what is lightning. Then what are the things we can do inside arrow? What are the things we can do inside arrow? That means inside arrow, we know what is telephone wires, electric wires, and metal obstacles or metal furniture. These are all good conductors of electricity, so you may not handle while lightning. Then also, if you may not use what is a wired phone. You can use what is mobile phone or cordless phone at that time. And also you may not phone to a person who is using a wired phone at that time. That also can get lightning to that person. So that also we want avoid. Then some methods to protect us. That means among that one is what is a lightning conductor. Lightning conductor or lightning arrest. That means a lightning conductor is a device used to protect the buildings from getting lightning conductor is a device to protect buildings or houses from getting, that is electric passage whenever there is lightning. That means what is the use of this lightning? That means protect a building from the effect of getting lightning. That means without getting lightning, this lightning conductor can protect. That is the purpose of this. A lightning conductor is a metallic rod. Lightning conductor is a metallic rod, and it is passed through the wall of the building, and its ornament is above the buildings in air, and other end is buried deep in the earth. Other end is buried deep in the earth. This end is above the earth. This is building, and this end is above the building, and this end usually with the sharp edges. That means this end is with the usually sharp edges, because we know what is whenever there is a charge is formed, whenever there is a static charge is formed, the charge accumulates more at the sharp end than at other parts. So this is with what is a sharp end. This metallic conductor is with a sharp end on, because we know what is when there is a formation of what is a static electricity or static charge, more charge is accumulated at the sharp end of the conductor than at the other region. So sharp end there is more charge is accumulating. Because of that, this lightning conductor or lightning arrestor with a sharp end, and this passes through the walls of the building, and the other end is buried deep in the earth. So whenever there is an electric charge come near this one, that will passes through this metallic conductor to the earth. We know what is earth means, an electron bank that can give enormous any amount of electric charge, or also it can accept electric charge, because of whenever there is a charge is coming, that can discharged through this without getting any lightning effect on the buildings. And also some other, that means metal columns while constructing the building, and also water pipes, electric circuits, etc. also prevents this lightning up to a certain extent. That is electric charge that also passes to the earth. But one things we want to remember, while or when there is lightning, do not stand near these electric devices. That means don't operate electric devices such as TV, computer, etc. Because that is very easily can get electricity passing through it, and also if we work it, we can also get electric shock. But glowing the bulb, when if the bulb is glowing, then that is a problem. That is not a problem. If the bulb is glowing, that is not a problem. That does not affected by the lightning. Now, what are the things you want to remember about the phenomenon of lightning? How this happened? First of all, we want to remember mainly how this happened. How? Because whenever there is a thunderstorm, what happened? Air molecules moves upward, and water droplets moves downward. This vigorous movement causes what is electric charge, and on the top of the cloud, what kind of charge is forming usually? That means there will form positive charge, and its bottom is a negative charge. Then near the surface of earth also positive charge formed. Is air is a conductor of electricity? No, it is not a conductor of electricity. Then how electric discharge take place through this? When the charge accumulation becomes enormous, that means at a huge amount or very large amount, the air cannot prevent the flow of charge. So this positive and negative charge, what is meets, they come together. Then there will form a streak of bright light with the thunder. This streak of bright light is the lightning, and the sound produced is the thunder. Where does this lightning can occur? Lightning can occur in between the clouds, in between the charged clouds, and also charged cloud and the earth. There can be lightning occur. What are the things we want to remember whenever there is a lightning? What are things we want to remember? Open places are not safe to us. If there is thunder, it is a signal to rush to the safer place. Then another things, what is some of the things that we can do. Suppose in the bus or cars, close the doors and windows for the safety. What you want to do? That is in open bike, open car, truck or bike or operating some construction machines. These are all dangerous to get lightning, or it is very easy way to get lightning. So we want to take precautions about that. Then suppose we are in a forest where we want to stand the tallest tree or shortest. We want to stand near the shortest tree. Then inside the house, do not operate electric appliance during what is thunderstorms or lightning. It is also we want to take precautions. Then other things we want to remember is that what about a lightning conductor? Lightning conductor means it is a device used to protect buildings or other structure from lightning. It is a device used to protect from buildings or other devices such as what is this tall buildings or buildings and or houses etc. from getting lightning. Then how it is constructed means it is with a metal rod. Its owner is outside the building, a little more height, and that end usually sharp. Because why we use a sharp? Because sharp end there accumulate more charges than the other end. Then the other end is buried under the earth. In this way we can protect it. Okay, these are the things you want to remember about lightning and how we can avoid getting electric shock by lightning. That you should remember, and its precaution you should take. With this all we can wind up today's class. Okay, thank you.